Hey everybody, I'm going to go over this worksheet, and the reason I'm spending a lot of time on compound interest is because I think it's so fascinating, and this is really kind of, the principal basis of how Americans are expected to retire is we're expected to save up on our own and find something with compound interest. So I'm giving you the formula here for compound interest. This is what we're going to use to fill out the equation, and I'm going to do the first two problems for you, and then I'm gonna show you how the chart works in the back. Okay, so um, uh, simple interest, by the way, is just principal times 1 plus the interest rate, and then as you can see, the compound interest is a little bit more involved. And P is principal, M is times a year, so you might have something that compounds monthly, so there's 12 months in a year, so M would be 12. If it compounds annually, it would be 1. And if it compounds like semi-annually, that would be 2. Okay, question 1 says, suppose you have $5,000 to invest, and you can get 5.5% interest paid out annually for 1 year. Alternatively, you find that you can get the same interest rate compounded monthly. So this is asking you, what's the difference between compounded monthly and compounded annually? Is it a big deal? Is it worth it? So the amount is going to be equal to the principal, which is $5,000, times 1 plus, and again, this is just this up here. The rate is not 5.5, it's 0.055. The rate, this is in percentage, you need to change the rate to a decimal. And then for the first one, we're going to say that this is 1 time a year, so annually, and this is for 1 time a year. And then the other one is going to be the same $5,000, the same rate, but this time it's going to be compounded monthly, so 12 times per year, and this time it's going to be 12 times per year times 1, which is going to be equal to 12. So we'll get out the calculator here, and we'll do $5,000 invested times 1 plus 0.055 divided by 1 to the first power. And I hope you guys can see that. So $5,275. Okay, now you can also, let me see if I can get this light a little bit better. You can also simplify this a little bit. This is the same thing as saying $5,000, and then 0.055 over 1 is just 0.055. So you could say 1.055 to the first power. This will be the same thing in your calculator. You can see how that cleans up a little bit. Okay, over here, we're going to do 5,000 times 1 plus 0.055. I'm going to put this in parentheses. Divided by 12 times a year to the 12 times 1 is 12. And I need to put that parentheses there to the 12th. There we go. So 5282. So the difference between these two, this is compounded once annually. So this is like 5.5% interest essentially. since it's 1 year and it's only compounded once. And then if you got it to compound annually, just in 1 year, it's worth an additional $7. Okay, and a little bit extra, but mainly $7. So $7 on the first year. That might mean something to you. I mean, to me, $7 is, it's maybe one extra time eating out at McDonald's. But again, that's 1 year. Okay, number 2 says we're going to illustrate the power of compounding over time. So now we're going to have 10 years. So it's the same $5,000 at 0.55 to 10 years. So we have the amount is equal to $5,000 times 1 plus 0.055 divided by times per year is going to be 1. And then now it's going to be 10. So now it's to the 10th power. So $5,000 times 1.055 to the 10th is equal to 8540 and 72 cents. So, hey, that is like $3,500, right? Over 10 years. And so who wouldn't want $3,500 free dollars? This is the power of compounding over time. If you could get the same deal with 12, so all we would do is go back here and do 1 plus 0.055 divided by 12 to the 120. 120 is 12 times 10, so 12 times per year times 10 years is 8,655. So you get an extra, $120 if you compound monthly. Okay, so now I'm going to ask you to fill out this table, and I'm going to give you $1,000. So maybe, you're going to graduate high school and grandma gives you $1,000 or a friend gives you $1,000. Maybe you work for a company and you get a one-off bonus of $1,000 and you have a choice. You can spend the $1,000 right away, or you can save it at 10%, till whenever. How much is it worth in the future? So this is talking about the future value of money. The future value of money is how much money is your money worth in the future. Your money. You know what your money is worth right now. You know it can buy you, but if you don't spend it and you save it, how much is it worth for you in the future? So I fill out some of these for you. And I'm going to show you where I get these numbers from. This is going to be a $1,000 principal, and it's going to be 10%, so 0.10. And then it's going to be at over 1 because it compounds annually. And then this is going to be the years that you go into. So the first one would be year 1. So $1,000 times 1.1 to the first power. That's year 1, $1,100. Okay, so how much compound interest did you get? Well, you got $100 because you have $1,100 in your account now. You started with $1,000 in principal, so you made $100, and you can't change from the previous year because there was no previous year. So let's do $1,000 at 10% compounded annually for 2 years, and that's $1,210. $1,210, you earn $210 of compound interest in that time. What's the change from last time? Well, last time you had $100, this time you have $210. So you can see, you had 210 if you minus the principal, so $210. Last year you got $100, so what's the difference? The difference is $110. So that's where you get $110 there. The first year you made $100, the next year you made $110. It's a $110 difference. So year 3 is $1,000 at 10%. To the third, because it's year 3, $1,131. So it would be $331. I don't know if I said that right. Okay, so how much interest did you make? Well, you started with $1,000, and now you have $1,331, so you made $331. So last year you made $110. What's the difference? I'm sorry, last year you made $210. So there's a $121 difference. I forgot, I didn't subtract out the $1,000 principal. So you have a $121 difference. So 1 year of compounding interest, or I guess 2 years, it gave you a difference of between year 1 and year 2, the difference was $110. The difference between year 2 and year 3 was $121. So you can see it's not linear because the rate or the growth increases every single year. So I'd like you to fill out this table. This is simple interest over here. You'll see I got it started for you. You just have 2 more to do using the simple interest formula in the front. And then answer the questions. Some of these are opinion questions. Some of these are explain your understanding. And then turn it in on Google Classroom. Make sure you submit it in Google Classroom. Don't hit share with me. Okay, have fun.